Tonight's special guest speaker, Dr. Paul Gray, is the science coordinator for Everglades restoration with Audubon, Florida. Throughout his career, Dr. Gray's work has focused on habitat connectivity on public and private lands, water issues in the Everglades, and bird conservation in the northern Everglades and Lake Okeechobee watersheds. Dr. Gray holds a bachelor's degree from the University of Missouri, a master's degree from Texas Tech, and a PhD from the University of Florida, Go Gators. He received awards for his work from the Everglades Coalition, the Florida Wildlife Federation, the Florida Cattlemen's Association, the U.S. Fish and Wildlife Service, and the National Audubon Society. He's a charter member of the Florida Grasshopper Sparrow Working Group and a co-chair of the Snail Kite Coordinating Committee. Tonight, Paul will be sharing with us stories pulled from his 35 years of work on Lake Okeechobee and the Northern Everglades. Please give me a big round of applause as we welcome to the stage Dr. Paul Gray.
Okay, can you hear me? All right, super. So that's not the title that you saw on the bill out there. So I'm Paul Gray. I work for Audubon, Florida. I'm a staff scientist in our Everglades program. And my principal responsibility is the Everglades north of Lake Okeechobee, which goes all the way to Orlando. And so what I'll talk to you tonight about is kind of what Lake Okeechobee's like. It's such a big, wonderful ecosystem, but it's got some pretty big problems, as you guys know, and they come to you too. And so we'll talk about what the lake is, what we've done to it in the past, and what we need to do to fix it, and have some fun along the way. So, how many people have seen me talk before? So you know this is me in 1938. This is Marvin Chandler. He's the very first Audubon warden on Lake Okeechobee. You notice he has two belt buckles. One of them is a badge. And this was back in the days when we didn't have we didn't even have a Fish and Wildlife Conservation Commission. So Audubon would actually hire people and the state and feds would deputize them, and they would go out and enforce the game laws. And so Marvin carried a badge and a gun, and he was the warden on Lake Okeechobee back in the 1930s. He started in 1936, so this is the 89th year of our program. I essentially have his job, but they don't let me carry a gun. What's he holding? Water moccasin, 5 foot 11 inches long. See how fat it is? They had been out on King's Bar on Lake Okeechobee, and they were at a glossy ibis nesting colony. And at that time in the 1930s, we think 95% of all the glossy ibises nesting in North America were nesting on Lake Okeechobee. And so they were protecting it. He had taken some photographers out there because it was such a novel thing. They couldn't get around the snake on the way back, so they ended up killing it. So they opened it up, and in its stomach, it had a tricolored heron egg, 3 glossy ibis eggs, another egg that was partially digested. It had a baby American egret and an adult glossy ibis in it. So if you find water moccasins, they're fun to play with. And so these are glossy ibises now. They're actually fairly abundant on the inland. You know, back then we only had about 1,500. So we always have this history in Florida of, losses and catastrophes, but this is a success story that is really nice. So now the next picture I'm going to show you, there's a guy named Mark Perry, and I have a bone to pick with him. He's the co-chair of the Everglades Coalition, and so this year at our meeting, which just ended this weekend, they decided to close the conference with a swamp bash, and they decided to elect a swamp king and a swamp queen, and I didn't know anything about this stuff. And guess who won? And that's Charlotte Roman. She's on the governing board of the Water Management District, and so we think her staff tried to stuff the ballot box to make sure she got the swamp queen. But anyway, there's the crown. This was made by Michelle Arquette Palermo, and those actually are python bones and grapevines and Spanish moss, and I didn't wear it tonight, I'm sorry. Okay, so back in the 30s, the governor and cabinet, in order to give Marvin some legitimacy, actually took parts of the Okeechobee Marsh and designated them as wildlife sanctuaries. And that way it just kind of gave him a little bit more enforcement authority. Of course, you guys have heard the story of Guy Bradley, who got murdered by poachers in the Florida Bay. Columbus McLeod got killed in Charlotte Harbor. We had a guy in South Carolina get killed. The guy on Orange Lake got shot. He didn't die. So this was, imagine enforcing game laws on Lake Okeechobee in the 1930s. But Marvin had a full career and he didn't get shot. Okay, so this is the good old days. The headwaters of the Everglades is up there at the very top, right if you land at the Orlando International Airport, that's right where the headwaters of the Everglades is. And everything from there flows to Lake Okeechobee. It's Reedy Creek, Boggy Creek, and Shingle Creek. And then all the water would go into Lake Okeechobee, and notice there's no connection to the St. Lucie. No water from Okeechobee made it to the St. Lucie because there's a ridge between the lake and the river. And some water actually went down the Caloosahatchee on the other side, but most of it went to the Everglades. This is in the good old days. So the lake is really big. It's about 30 by 35 miles, depending on which way you travel it. When you get in the middle of it, you cannot see shore in any direction, and you may only be in 8 feet of water. It's very, very shallow. The bottom is right about sea level. And even from an airplane, you really can't see the other shore. So it's just this huge lake. And it's so big. You recognize this rain shadow? So when the land heats up, and especially in the summer, this is actually in February, in the summer when the land heats up, the air rises, and when the air rises, it makes our summer thunderstorms, right? But the air above the water is not heating up because water circulates. And so what happens is you get this rain shadow around the lake because the thunderstorms aren't forming above it. And so that area behind the lake is in the rain shadow. It affects its own climate. And here's a climate forecast from the Water Management District, and you can see the scale down here, that brown is significantly less rain than the areas right around the lake and right above it. It actually does that. So the middle of the lake is full of all kinds of life. These are scaup, they're diving ducks. When we started flying surveys, we found out there were sometimes hundreds of thousands of them out there in the middle, and no one even knew it. These boats here are actually commercial fishing boats. Those little boats, they have nets in that are like 1,000 yards long, and they take them out there in purse seine, and they circle them, and then they are able to keep catfish and bluegill, and they sell those commercially, and they have to keep all the other fish. They have to throw back crappie and bass. But anyway, so there's commercial fishery that's out in the middle of the lake. And they make them stay in the middle because they have conflicts between recreation and commercial fishermen. So this is a fish that, what's that fish? Yeah, crappie, or speckled perch, they call them inland. And so in Okeechobee, we catch as many as, more than 1 million a year when things are good. That's more than the whole rest of the state combined. And these are all crappie fishermen at the mouth of the Kissimmee River. This is the season to catch crappie. Some people really like to go after it. Okay, so this is what most of us know about Lake Okeechobee. This is the cyanobacteria bloom of 2016. We had a great big El Nino in the spring, and it ran a whole bunch of water into the lake with a whole bunch of nutrients, and the next summer, boom, it blew up. Notice where the St. Lucie Canal comes out. It's right there, right next to the bloom. You couldn't possibly put a canal at a better spot to be able to release algae blooms, unfortunately for you guys. And so here's 2018. Again, this is the satellite images, and you notice that red and yellow one down there, that's in July. So, this is 2 years later, it's happening again. And the area that gets in, the middle of the lake's like 300 square miles. So that's a lot of algae. But actually 1/3 of the lake is marshes. The western side especially is mostly marshes, and you can fly over it, and when you get back in the marshes, you're far away from the algae, you're far away from the blooms. And so here we are during the 2018 algae blooms. Look at how clear this water is. And that's periphyton, and that's Eleochris, and this is just an Everglades type habitat. And so at the same time we're having algae blooms, this is like 2 miles from the open water of the lake. This is a rainfall driven part of the lake. And so I'd take reporters back there and I'd drink the water and they'd be like, ugh. And actually one of them picked up on it and he did a little spiel. I'm in Lake Okeechobee and I'm drinking the water. And it went on the 6 o'clock news or something. But that's part of what this lake is. It's so big, it has so many different things that even when certain parts of it are really screwed up, some parts of it are just really wonderful. And here they are. What? And this is Dr. Evelyn Geiser and her student Hannah Innocent. And these are paraphytometers. They put these out and they're trying to find out what kind of periphyton is growing in Lake Okeechobee. And basically, when they did their water quality analysis and all that, she said, this is just like the Everglades. Because Okeechobee really is part of the Everglades, or it was. We've kind of cut it off, but parts of it are still just wonderful at times. And this is real hard to get to. You got to have an airboat. You got to drive a couple miles back, but there it is. And here's emergent marsh. That little tiny dot in the sky is snail kite. And I'm going to talk about emergent marsh and submergent marsh. So this is emergent. This is the stuff that grows up out of the water, like cattails and flags and grasses and stuff like that. And this is submergent marsh. That picture up in the upper left, that's underwater. See how clear it is? That's eelgrass, and that's the stuff that the bass fishery lives in, the crappie fishery lives in. The picture on the right is after one of the hurricanes, I think Ian, but you can tell that stuff is in trouble. The lake has a mud bottom in the middle of it. When it gets stirred up, it gets really, really turbid, and that stuff doesn't have enough light. This is part of the reason why we keep losing our submerged aquatic plants, because they can't live in that dirty water. And this picture here is just, there's a bunch of SAV out there, and these are coots and ducks and stuff like that. Underneath that, there's another ecosystem full of fish and grass shrimp and stuff. So this is, when the lake's good, it's like that upper left. When it's bad, it's not. Okay, so what's this? What's a great blue heron have in its mouth? See the leg on it? Right next to its beak, sticking toward its throat? That's a leg. This is a siren. It's a salamander. Yeah, we have aquatic salamanders in the lake. There's actually a couple different kinds of them. I virtually never see them, but these birds can catch them. But this is just one of those weird things that are down in South Florida wetlands and in Lake Okeechobee too. Okeechobee gourd. This is an endangered plant. It's really closely related to some gourds in Mexico, and we think that it was traded around the Gulf Rim back, when the Indians were living here. The seeds are very nutritious, and this little plant, actually, the leaves are really resistant to a lot of things that, how many squash and pumpkins and gourds do we eat? We eat a lot. And so it's a really important economic crop, and there are some guys out here trying to get samples, DNA samples of these guys, to try to figure out how can these guys have this automatic resistance to a lot of the pests that our crops have, and if you can figure it out, you can splice it in. So this is one of those values of biodiversity that a lot of people don't think of. But anyway, so these little guys are in Lake Okeechobee, and there's a little patch of them up in the St. Johns. So upstream of Lake Okeechobee is the Kissimmee Basin and Fish Eating Creek and Indian Prairie and all that. And the watershed is really, really flat. And we know the story about the Everglades where it rains in the summer and it fills up with water, and then during the winter it draws down. Well, the Kissimmee Prairie does the same thing. And so this is all native cover. The kind of greenish stuff is palmettos. The gray area is wetlands. They're a little bit lower. And so by the end of summer, this is on the Kissimmee Prairie Preserve, you'll be standing in the palmettos, you'll be ankle deep in water. Everywhere you go, you're in water, because this is not drained. And so in the good old days, what would happen is the watershed would fill up with water in the summer, and then all winter long it would be slowly, slowly draining into Lake Okeechobee. And so it would take 6 to 8 months for all this water to drain out of the watershed. This is important to remember, because when I talk about what we did, it's not like that anymore in most parts of our watershed. And of course, these are the stars of the show. These are 5 endemic prairie birds. So what's upper left? Florida sandhill cranes. What are those little fuzzy things? Colts. I had some Boy Scouts say they were chickens. So upper right, yeah, Florida burrowing owl. Lower right, caracara. Lower left, mottled ducks. They're here and they're in Louisiana. And the star of the show in the middle, Florida grasshopper sparrow. So all these are found here in Central Florida, and they're not found breeding anywhere near here. Now there's cranes that breed up north, and grasshopper sparrows that breed up north, and there's ducks that breed out west, and owls and caracaras, but we have these isolated populations that are stuck here in the grasslands, and so these are birds of great conservation. That's why part of the reason I'm here is because Audubon was interested in these birds. And here we are at the Avon Park Air Force Range. You don't think of a bombing range as being a good place for endangered species, but this is one of the last holdouts. And the grasshopper sparrows have fallen on really hard times. We started a conservation breeding program for them. And so this is when we released the 1,000th bird at Avon Park Air Force Range. And these are mobile aviaries. We take them from the breeding facility, we leave them overnight, and then we open up the door and let them hop out. They don't fly away, they walk. They're sparrows. But anyway, so these are the habitats of the watershed of Okeechobee. And of course, we have pine flatwoods, some really beautiful landscapes up there. This is Lake Istapoga. I live right on the north side of this lake. 5 of the 10 largest lakes in the state are in the Okeechobee watershed, Okeechobee included. What's this? Swallowtail kite. What are those? Those are all swallowtail kites. So if you go to Cowbone Marsh on Fish Eating Creek, and you look out in these trees, you can't quite make it out. Yeah, so swallowtail kites are weird. They gather in these flocks before they fly across the Gulf. They winter in South America. And so this roost has maybe half of all the swallowtail kites in North America in it during the month of July when they're getting ready to go to South America. And so this is a really high priority bird site for us. Luckily it's on the FWC Fish Eating Creek Wildlife Management Area, and so they can kind of protect these guys from people getting in there and causing mischief, because when you have half of all the population, and especially as such a glamorous bird, you really want to make sure you take care of it. And what they're doing is they're trying to get fat. They got to fly across the ocean. And flying 99% of the way across the ocean is not good enough. Yeah. So here they are. These are some satellite tracks. This is from Avian Research Conservation Institute, Ken Meyer's group up in Gainesville. But they track them across the ocean, and so they got to make that whole flight. And they soar around a lot, but when you're above the water, remember we don't get thermals above Lake Okeechobee's water? Well, the Gulf doesn't do that for them either, so they have to flap all the way. They're used to gliding, they have to flap, so it's really a hard flight. And so the way they do it is they get really, really fat, and they can burn their fat while they fly. We can exercise, we'll die with our fat reserves on us, but birds can burn, they burn their fat. And so, that's their gas tank. So here's one that took off from Florida, and it got caught in unfavorable headwinds, and look at where it ended up. It actually was up for 3 days, and it landed in Texas. So not only you got to make it across the ocean, but you got to be ready for bad weather and getting stuck. Here's Mia, short for Miami. She was banded in Miami, and she took off from the Yucatan trying to come back. She got caught in headwinds, and she went back to Cuba and landed. And then she tried to fly from Cuba to Miami, and look where she went. Yeah, so then she went along the Gulf, and then she flew across the Gulf again, and she finally made it back. Migration is hard. And this is bullfrog. And he took off, March 8th, and on March 10th he was up there, and on March 11th he was stuck, and he swung back, and on March 12th he was almost back to the Yucatan, and he didn't go back. And he went back north, and they lost his radio. They can last on the wing. These guys can last about 3 to 4 days. So again, it's really important when they're here in Florida, we feed them. So birds can do unbelievable things with migration. This is a red knot. And red knots, before they migrate, these are guys that can fly for 6 or 7 days straight. Yeah, they'll fly all the way from South America to North America in a week. And so they do that by doubling their body weight. They literally put on so much fat, they double their body weight. And while they're doing that, their gizzard gets bigger, their intestines get bigger, their liver, their kidneys, because they're processing all this food and trying to beef up. And a couple days before they leave, they stop feeding, and they reabsorb all those tissues. They put it in their chest muscles. You know how steroids in people? We're nothing. And then they fly north, and they burn all that fat as they go, and they'll land with half their fat reserves gone. So this is, migrant Olympics that birds can do. All these little beauties were banded on Lake Okeechobee. They're on an island out there that we'd planted with some native vegetation, the FWC did. And so these birds were coming. And a couple of these birds, this is from Tyler Beck from FWC, he caught a couple of them the next year in the same month. because they're just like we are. If you go to a city and you find a good restaurant, when you go back, you go back. So they were back on the island. So, you know, and again, these little guys, they double their body weight too. They weigh about as much as 4 pennies, and when they leave, they weigh as much as 8 pennies. Yeah, imagine trying to build an airplane that weighed that much and fly it across the Gulf. And more of them. Aren't they lovely? So again, these are migratory birds, and these are what we call neotropical migrants. North America has more migrating birds than any continent. And so you look where Florida is, we're kind of the neck of a funnel. Not everybody goes through Florida, but we are the neck of a funnel. So, you know, I talk to people about the importance of Florida, and we got to save our birds. You know, we're really saving birds that breed in Canada, birds that nest or spend the winter in South America, and we are the last gas station before they leave, and we're the first one when they get back. Yeah, so we're saving the Everglades not only for our own interest, but for a continent's worth of birds. And they're pretty and they sing and we like them for that, but they actually are very useful. Here's a little yellow warbler with a caterpillar in its mouth. They put some tents over trees in Missouri that birds couldn't get through, and they broke out in infestations of insects. And they had 13% leaf loss in the trees 25% leaf loss in the trees that were bird-proof, only 13% in the forest next to them. And so that extra leaf loss actually slowed down the growth of those trees. And they've done this in a whole bunch of places. And so if you're a forester in Pennsylvania or Nova Scotia, you care if these birds come back. You care if the Everglades gets restored. You may not know it, but this is happening. And birds do all kinds of other things. Like, you know, we're Audubon and we're birds, so I got to talk about birds. So, and they're not the only things migrating. Turns out we know monarchs migrate. Dragonflies migrate, bees migrate, all kinds of butterflies migrate. So the whole heavens are full of migrating creatures. Okay, back to Lake Okeechobee. So an interesting thing about Okeechobee, I talked about how the water starts up at Orlando and it comes to the lake. All the water upstream of the lake goes into the lake. It's like the neck of an hourglass. And that red star is where I live. And when it gets in the lake, it's going to go somewhere. So Lake Okeechobee is like the single most important water management feature because it's 100 miles from Okeechobee to Florida Bay, 100 miles to Orlando. It's this huge intersection where the water gets there. It's got to go somewhere. And if you drive down Cantor Highway to the cemetery down at near Port Mayaca, this marker is there, and it says to the 1,600 pioneers in this mass burial who gave their lives in the 1928 hurricane. This happened in 1928. We think probably 3,000 people drowned. And the hurricane went over Lake Okeechobee and made a 12-foot storm surge in the middle of the night, and people, you know, in Belgrade back then were living in tar paper shacks and things. And so the stories about it are just horrible. And this ended up being a mass grave because the bodies, it was summer and they couldn't clean them up, and you don't want to read about it. And there's a hurricane before that in Moorhaven a couple years before, and it drowned about 400 people. So the storm surge out of Lake Okeechobee, 12 feet high, just like around the ocean. And so in 1948, we had some really wet hurricanes, flooded all kinds of stuff. And so we went to the U.S. Army Corps of Engineers, the state of Florida did, and said, will you help us drain our state? And they said, sure. And so they took this original design over on the left, and the engineers were like, well, okay, the quickest way to get water out of the state, this microphone. Okay, got to have a coach. So the quickest way to get water out of Lake Okeechobee, you don't run it 100 miles down to Florida Bay. That takes forever. You run it to the St. Lucie. That's the very shortest path. And so the biggest structure on Lake Okeechobee is the St. Lucie structure. You guys were designed to get the worst of the water. And the Caloosahatchee has the second worst. And so what happens is if you look at that middle thing, the flow to the Everglades is too low. So the Everglades is not getting enough water. You're getting too much. The Caloosahatchee is getting too much. And Everglades restoration is designed, we need to rebuild the system. We need to catch the water and send it south where it's needed and quit dumping it east and west. And that's what we're building right now. I'll get into that in a little more detail, but that was the thing they did. And one of the engineers in 1949 said, you know, Florida's got to realize you got two water problems. One is flooding, and we built you a really good system to deal with flooding, but the other is drought. And if you overuse your drainage, you're going to have worse droughts. And then we went ahead and did it. So here's a picture of the CNSF project that they designed in the 1940s. It actually had a lot of pretty smart features in it, but it had some other things that were pretty bad. Here's a satellite photo. You can see the red. That's the Everglades agricultural area. And you can just see how much Florida has been diced and sliced by people. So we've changed a lot of things. And the drainage system really has made our lives here possible, but it's caused these other problems that we're trying to figure out how to fix. Because, you think about a drainage system for the 1940s, it's a jalopy. What if you had a car for the 1940s? And you could get around, but it wouldn't be very good. So we're trying to update it now with a new water management system. And so when I showed you the picture of the consuming prairie where the water ponds and stays for 6 months, well, a drop of water that lands in either of these places is gone the next day. And where's it go? It goes into the lake, or it goes into the estuary, or it goes somewhere. And so now we drain very, very quickly, and we get these huge glugs of water during the wet season. And so to kind of illustrate how that works, I have some slides from the aftermath of Hurricane Irma, and you could plug in Hurricane Ian, Hurricane Francis, Hurricane Jean. This kind of shows you how the system works. And of course, we don't have hurricanes every day, but when you stress your water management system, you see what the benefits and limitations are. So we'll talk a little bit about some of what happened in the watershed. So here's the hydrograph of Lake Okeechobee, and you notice it was 11 feet in the summer, and it ended up clear up at 17 feet. And that last 3 feet of rise is Hurricane Irma. And you notice it was at 16 feet the year before, and it went all the way down to 11 feet. Well, what we want for the lake is to stay between those two red lines. And so it goes down 5 feet, goes right past them, then it goes up 6 feet, goes right past them. And so this is part of the problem. The drainage helps it drop so fast because there's no base flow once you start draining water. And then when the hurricane came, all that water glugged right into Lake Okeechobee, got up to 17 feet. And then what happens to you guys? Yeah. And so I talked about the storm surge at Belglade. See that green line on top? That's that green dot on the far side of the lake, the S131. And the purple line down at the bottom is the S352. And this is the storm surge in Lake Okeechobee. And so when the hurricane came in, the water on the west side of the lake was above 20 feet, and the water on the east side of the lake was below 10. Yeah, it really sloshes around. And that's part of the reason they built the Hoover Dike, is to try to prevent people from drowning. Because when the 1928 hurricane hit, not only it killed a lot of people, but there were bodies that were found like 8 miles out in the Everglades because the water just went so far. So, the dike has been a problem, but it also serves a very important purpose. And so after the hurricane, you can see a bunch of vegetation piled up along the shoreline. This picture here, you see Taylor Creek, Nub and Slough, S191. That's water flowing into the lake, and look at the water that's in the lake. That's that mud. Remember I showed you that picture of the SAV in really muddy water? Well, that's what happens when the hurricane stirs up the mud on the bottom of the lake. So when the cattails roll up, they actually roll up, and they make a bunch of rolls, and it looks kind of flat, doesn't it? But this airboat got on it, and he was trying to get across there, and he went over one of the rolls, and his bow went down, he went right under the next one. And so anyway, luckily he was right near shore, and they had to bring out a track hoe to lift all that vegetation off because it's so heavy. But anyway, that's not my boat. Okay, so I'm going to talk about the submerged aquatic vegetation and the emergent aquatic vegetation. And so this kind of brownish area on the outer edge, that's where the submerged plants are, the eelgrass and stuff. That's where the bass live. The green stuff is the emergent marsh, which is all the stuff growing out of the water. And so the SAV zone can be 50,000 acres, 75 square miles. The green zone is about 100,000 acres, which is 150 square miles. So really huge areas of marsh in Lake Okeechobee. And so this is from the outside of the marsh after the hurricane. And basically this area was vegetated all the way to that island back there. And you can see that the storm surge and the waves and all that really beat up the vegetation. So that was one of the first effects. And this dreadful graph, it's not as bad as you think. This is kind of what happened to SAV. The green bars are SAV, the submerged aquatic vegetation. And if you notice back on the left side of the graph, there's two really low numbers, and that was in 2005 and 6, because remember what happened in 2004? Francis, Gene, Charlie, Ivan, and it came in and it drowned out all the plants. But then in 2007 and 8, we had a drought, and the lake went clear down. See how low that black line is? That's the lake level. And then look at how high the green was afterward. So when the water gets down, the SAV can regrow. And so we got 50,000 acres. But then this top bluish line, that's the harm threshold in the lake. And notice during the 19-teens, we hit it year after year after year after year after year, and you can see the SAV acres going down, 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 down. So deep water gets rid of the SAV. And so this has been kind of the problem with Lake Okeechobee. And this is with the old schedule, that the lake just keep hitting high levels and we keep losing the SAV. And when you do that, your bass fishery crashes. And so again, this green line is the SAV going downhill. The blue line is the bass population going downhill. And so this is part of the concern for the lake. And I'll talk a little bit more about the recession, what the Corps is trying to do. But this is partly why they're trying to do it, is because if you run out of bass in Lake Okeechobee, that's not a good thing. So this is a cross-section of the lake, okay? And the SAV in the lake, that submerged aquatic plant zone, and it's just like your seagrasses in the estuary. When you lose your seagrasses, you lose your sea trout, your red drums, I don't even know what all fish that live in your seagrasses, but when they're gone, it's just gone. And so that's what's kind of happened in Okeechobee. And so see how this is all dirty down here in the lower end? They did a really good job of shading, and that's a depiction of the turbidity in the lake. And only in that white zone up at the top can you get enough light penetration. And when the plants are growing up to 14 feet, you don't need to draw the lake down because they're up at the surface and they're getting light. But when you lose them, we've got to get sunlight in that 9 to 11 foot range, and you notice it's dark. So the problem with the lake is the turbidity doesn't let the light penetrate. Once you lose your plants, you got to get light on the bottom to hit the seeds to germinate them. And that's a hard thing to do. And so the Corps is trying it. We'll see how it works, but that's kind of the reason they have to make it so low, is because once the plants are gone, you got to get the light all the way to the bottom, not just to some plant standing up. And so here's what happened to the crappie population after the 2004 and 5 storms. You notice it just tanked, 7, 8, 9, 10, 11. I mean, it just took years to recover. And so obviously you want to do this as rarely as possible. So now we're back to what happened with Irma. And I'll point out this top area, this green area, that's the upper Kissimmee Basin. That's where Orlando is and the town of Kissimmee and Disney and all that. And it's 1 million acres. And so we're going to look at what happened up there during Hurricane Irma. So this is next to Lake Toho. The first thing you think of is, who gave a permit to put houses there? But they're there. And these people are flooded. And so they have to get rid of that water as fast as they can. And again, part of this is we didn't do a good enough job keeping houses out of low spots, but these people definitely need help. And so this was right after the storm, September 13th. And so this is the hydrograph of Lake Kissimmee. And what we want Lake Kissimmee to do is follow that red line. Well, you can see where the storm came in and it went, because all the water, but notice how fast the water got out of Lake Kissimmee. Yeah, by the end of October, by the beginning of October, it was already back. And so that's 1 million acres. That's 40% of the Okeechobee watershed that within a couple weeks it was drained. Yeah, and then where's that water coming? And then you look at the line through the December and January and February, they're in a drought. They're in a drought by December. The lake's low. It's because they drained all their water away and there's no more water and the lake's going down. And so this is part of the problem we have in our watershed, is all this water went to Okeechobee and to you, and it doesn't stay up here. We need them to keep more water up there. This is the disembodied floodplain of the Kissimmee River. But if you look at the middle one, that was in December, again, a couple months after the hurricane, and that should all be blue or at least green, and you notice how much red is in it, because the river's in a drought too. Now this was before we had the river restoration functional like it is now, so they weren't quite ready to keep it flooded, but again, this part of the watershed's already in a drought in just a couple months after a hurricane. and here's your estuary. And so the blue on the bottom is Lake Okeechobee releases. And you notice the bottom marker there is 2000. You never want, that's the really, you get harm almost immediately from Okeechobee water, but you get to 2000, that's like the serious harm line. And you notice the Okeechobee water, you notice the spikes there from your local basins, they're color coded. One thing about your estuary is you'll get a rainstorm, the water will gush into the estuary, and it'll stop because your watershed's only so big. And so all the oysters and everybody that lives in the estuary know that, and they just hunker down for a few days and then the water goes by. But look at how persistent those Okeechobee releases are. They go on for months. And so those guys hunker down, and they hunker down, they hunker down, they can't make it. And so that's one of the different things about Okeechobee. Not only it's an add-on problem to you, but it's a more persistent flow pattern than your estuary organisms can take. And that's part of the reason why it's so horrible for your estuary. And by the way, I work for a statewide organization, so it's my estuary too. And everybody says, send it south. Well, this was the Everglades, and these are the tree islands, and it was, up to its ears in water because the same thing happens to it. We pump all the water out of the human-built environments. We throw it in the Everglades. They just got the big rainstorm too. They get too deep. And here's deer running on the levee because that's the only dry place they can find. Just really not the situation that they want to be in. And so again, this is 2005 and 6. The big peak over there, up to 17 feet, that was Hurricane Wilma. And notice that the water came down in Wilma. We dumped enough water in 2004 and 5 to meet all the needs of all the farmers around the lake for 6 years. And during the spring of 2006, we were dumping on you, massive, massive amounts. I came over here and your estuary looked like the Missouri River, which I grew up next to, which people call a big mudslide. And then during the summer, it didn't go up very high. And then look at the next spring, or the next summer, it dropped clear down to 9 feet. And that dotted line is a water rationing line. And so we were in water rationing after we just dumped 6 years worth of water supply. Yeah, and so this makes environmentalists mad because our lake got wrecked, the estuary got wrecked, and it makes the farmers mad because they're in rationing. So this is part of the reason why Everglades restoration has so much support, is the water management system nowadays is not working well for anybody. And we're going to build more infrastructure, we're going to build more reservoirs to catch water when it's wet, and then we'll have more water left over when it's dry. And in a nutshell, that's kind of what Everglades restoration is trying to do. And so we have a new water management plan, LOSM. The biggest benefit for you guys is it's trying to stop the harmful releases from the lake. They're going to use the lake more of a buffer now. They fixed the dike and they're not as worried about its safety. But as you can tell, you're still going to get releases and you're getting them right now. The Caloosahatchee, the same thing. For a change, they need water from the lake. They used to get it historically, so they like a little bit, and the nutrients are not desirable, but the salinity is more important. And so they're getting more optimal flows, which is a great benefit to them. When we have cyanobacteria in the lake, they try not to release. There's an extra caution sign that says don't dump green water down the. But we're still going to have big storms. We're still going to have periodic releases. But the hope was that only every now and then and only quickly. So we'll see how that works. And also for the Everglades, we're going to flow more water south. Now that's still kind of limited because we don't have enough filter marshes to clean Lake Okeechobee as much water as we want to send south, and we're working to try to get more of those. But then for Lake Okeechobee, it's going to be deeper more often. And I showed you what Lours did to the lake where our SAV declined. Well, now it's going to be even more of a challenge, it looks like. And so with all this water going up and down and up and down, we still have half the Everglades left, but we only have 10% of the birds left. And that's because the remaining wetlands are messed up. They don't function like they did. So once we get all this stuff built and can kind of even out those water levels, the plants can respond, the fish communities and the shrimp and everybody like that, and hopefully we'll get our bird populations back to the levels we can. What do you call those things above the bird? Egrets. Yeah, this is the egret, and they spell it A-I-G-R-E-T-T-E-S. And this is what the plume hunters were hunting for. And they could make their weight, they were worth their weight in gold, quote unquote. And they shot out almost all the birds of the Everglades by 1900, and that's why we were hiring wardens and sending them out, and that's why people were shooting the wardens, because they were making a lot of money. But anyway, that's a whole different talk. Okay, so we're trying to get water levels under control. The other thing is nutrient levels. The goal for Lake Okeechobee for nutrients is that red line at the bottom. Yeah, the blue is the nutrient levels in the lake. And you notice back in the 1970s, it was right near that goal. But the green is the inflows. And so you can see how we've had these really high inflows into the lake for decades. And the blue goes up, 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 and it dropped down a little bit when we had a couple drought years, but it's gone back up. So basically, we've just got way too much phosphorus flowing into the lake, and that's what's stimulating these algae blooms. And this is going to be a long-term problem. And we're trying to figure out how we can put filter marshes north of the lake and other things to try to clean that up so that even when the lake gets a lot of water, it doesn't get the algae blooms. And so you say, okay, who do we want to hang for this problem? Well, in the upper chain of lakes, if you look at that pie slice of who's bringing in phosphorus, it's urban. It's all the people. It's all the food we bring in. It's neighborhoods. It's landscaping. But if you go to the southern part of the watershed and look at who's bringing in the most nutrients, the urban slice is pretty small. It's yellow. And it's agriculture, truck crops, improved pasture, dairy. So the deal is, it's not them, it's us. It's just people not being careful enough with nutrients, and we're not doing a good enough job of keeping people from putting too much nutrient out, and when they do put it out, of keeping it on their property. So that's a big focus, trying to clean up our watershed and stop all these huge imports of nutrients. And you guys know what happens when you get too much phosphorus. You get algae blooms and the fish kills, and the mud bottom in the lake is largely composed of dead algae. It's also a lot of silt and clay. Things like cattails grow, and of course tourism suffers. And so everybody's seen this sign on the left. This is the comparable sign from Lee County. If you work for the Chamber of Commerce, the last thing you want on the boat ramp is stay out of the water. So this is not what anybody wants, and this is what we got to fix. So this is a figure I found in a book that doesn't really apply to us directly, but I just want to make this point. These are blue crabs out of Apalachicola Bay, and little did I know they migrate all the way down to South Florida and back up to Apalachicola Bay. And so I spent a lot of time talking about bird migration and how important Florida is for birds. If you look at the fish in the ocean and how important your estuary is to them, there are spawning crabs and oysters and shrimp and snappers and groupers and sharks, and everybody's in your estuary spawning, and they're spread out into the ocean, and they populate the reefs. And there's migratory fish from New England that come south every year, then they go back north, and when they get south, they need to find something to eat, just like a bird does. And when they go back north, they need to be healthy. And so when we harm your estuary, when we wreck it, we're wrecking more than just that estuary. We're wrecking the ocean community around it. And so it's really important that we start doing better here. So, yeah. That's pretty good, but it hurts my feelings too. So I'm going to talk about what do we need to do. Well, here we have this lake that when things are good, it's lovely. But things aren't always good. And the way to fix this is we need to find places to put water. When it's wet, we need to catch that water up in the Okeechobee watershed so that it doesn't get too deep in the first place. And when you catch that water, you can clean it before it goes into the lake. So first, you catch it somewhere, then you clean it, you run it through a filter marsh or something, and then when you have it under control, you can send it south in a metered way rather than just dumping it in kind of an emergency pattern. And that's really the basic idea, is you catch it somewhere, you clean it, and you send it to where you want. And that requires a lot of infrastructure. So here's the Kissimmee River ditch, the C-38. Famously, the Corps dug this from Lake Kissimmee to Lake Okeechobee, and it drained all the floodplains, and bird use dropped 95%, and eagles quit nesting, and it was like a big mess. And so they said, okay, we're going to fill that ditch in. We're going to fix the Kissimmee River. And so here they are. There's a spoil pile that used to be there. They poured it into the ditch. There's a structure that they blew up and buried. And so they're taking the ditch out and letting the river meander again. And this is the river. And you can see the old canal running kind of right through the middle of there. You can see the footprint of it. And so look at this water. This is an environmental restoration project. Is this water going fast down a canal? No. Is it getting cleaned? Yeah. Is it furnishing habitat? So what we're trying to do north of the lake is do things like this, where we start restoring wetlands and restoring floodplains. And, you know, we're going to have to build some reservoirs because we can't restore everything because we live everywhere. But we can do a lot to try to slow this water down and start getting this. We didn't appreciate the value of these wetland resources, and now we have to spend $1 billion to catch water. So anyway, human beings. But, you know, the results are really wonderful. This is what the Chamber of Commerce wants. And up around Lake Kissimmee, they're going to start, this is Lake Kissimmee, Cypress, and Hatchnahaw, and all that hatched area is drained to marshes. We're going to start raising Lake Kissimmee up 1.5 feet higher, and that way it can hold more water, and that way during the long dry season, they can leak water out to the Kissimmee and keep that river floodplain wet. And in the process, we're going to reflood all these marshes. So again, this ecological restoration is helping us with our water storage and cleaning and habitat values. And here's the old citrus pattern where a drop of water has nowhere to stay when it falls. Here's a more modern design. We still are growing a lot of pounds of oranges on the area, but we also didn't do edge to edge. And when I talked to Joe about this, he was an engineer with Likes who designed it. And I said, why didn't you just drain it? That's what everybody else does. And he's like, well, you know, that's still a low spot. And you can drain it and put citrus trees in it, but every time it rains, the water remembers where it's supposed to go. And your trees just don't grow well. So rather than fight it, we just put the trees where they're going to grow. We leave the rest of it. We graze cattle. It's still got habitat. And so this type of human development is something we need to do more of. As you know, humans are going to develop. We just need to be thoughtful like this is. This is on Likes Brothers property. And here's a slide that all my development team hate because it's too cluttered. But anyway, reservoirs, north, south, east, and west. You guys have the C44 on this side to try to help you with your basin. The West Coast has a C43. The big Everglades Reservoir, that's the single most important project, and we're working on that right now. And Joe Negron was instrumental in getting that going. And then north of the lake, we also want to do some projects. So we're building like crazy. We're going to have a lot of projects coming online soon. C44 is already online. They're still trying to get it to work right, but it's there and we can use it. And upstream of the lake, not just big reservoirs, but we have all these wonderful resources, and we want to protect them. See the bands on the Caracara? She was banded at Buck Island Ranch, which Archibald manages, about 20 miles south of my office. And she was around, I saw her until she was like 17 years old. Yeah, so really neat to have a friend that you can recognize. And so a lot of these ranches, you know, look at this. This is a wetland in a ranch. The birds are using it. The cows are using it. And so one of the things we were trying to do is go pay people, say, hey, if you plug your ditches, hold the water when it rains, don't let it glug downstream on us, we'll pay you to do it. Because if we're going to spend $1 billion to build a reservoir, why can't we pay landowners to help us manage water? And that's actually becoming a more and more popular thing. Cattle industry is very low margin, and they're looking for other streams of income. And so these types of projects, again, we want to make the watershed as wet as we can in the future. And quite frankly, wetlands have higher nutrition vegetation than uplands. And so the cows like wetland vegetation better than they do the uplands. And so this actually does not hurt cattle ranches. It actually kind of helps them. There's just such a mania of drainage. Everybody overdid it, and then they went, where'd all our water go? So anyway, this type of stuff, natural solutions. Here's Allapattah Flats. This is in your watershed, and that's what they did. And so this water on the bottom, it's not glugging into your estuary. It's just sitting there. And again, they have, I think, a cattle lease on this property. But again, a natural solution. This is thanks to Maggie Herchalla. She was really a stalwart person saying, restore your wetlands. You build a smaller reservoir, and they did that. So I'm going to wrap it up. We're going to talk about, this is SEP. This is, you see Okeechobee, and we're headed to Florida Bay. They're going to do a lot of work in the Everglades to try to let water flow through it. Right now it's got a bunch of dikes and levees and the Tamiami Trail, and so they have to prepare to be able to release all this water into the Everglades and let it become sheet flow again. And so this is underway. They're building many parts of this, and so this is clearing the way for sending more Okeechobee water south and less on you guys. And the important thing about this, this is a schematic cross-section I put Miami on the limestone ridge there. You can see Biscayne Bay on the right and the Biscayne Aquifer. The people on the Lower East Coast, 1/3 of all Floridians, they get their drinking water from the Biscayne Aquifer. And if you look at the schematic, it only is about 80 to 100 feet deep. It's fed by the Everglades. That's what keeps it. And we have saltwater intrusion, and especially with sea level rise, there's more and more pressure from the sea level. And so for a long time, we could not get the delegation of Southeast Florida to support Everglades restoration. And, you know, it's like, guys, forget birds, forget fish. We're putting water on your drinking water. We're recharging your aquifer. And once that light went on, it's like, whoa. So this is the water supply future for South Florida. So we're not only doing this just for birds and fish, but what turns out to be good for birds and fish is good for people too. So this is a really important thing for us to understand is, you know, our water is our water. We need to take care of it. And so here's the interior of Florida. It's mostly dark. This is a place where we can do a lot of water projects, and I hope to keep it dark like that. I hope to keep it in agriculture. We got to clean up their nutrients and stuff like that, but they can do that. They're professional land managers. And I hope we can make this area a place that manages water well for the rest of us and not poorly. And with that, I'll close. I have a whole different talk on kites too, but anyway. So. So I guess we can do questions.
But we can kick one off. There's a question here from one of our Zoom viewers. Why don't we just dredge Lake Okeechobee?
Okay. No, that's actually a very good suggestion. The mud bottom in it is, it covers like 300 square miles. It's 1 to 3 feet thick. And until we get that mud out of there, the lake's never going to be very clean again. But it's such a big volume of mud that we don't, where do you put it? If you put it on a farm field and then they have a pollution problem, who's to blame? So there's a proposal to build a big ring dike in the middle of the lake that will hold all the mud, and we could pump the mud into it and filter it back out. I think in the long term, that's probably going to be our solution for trying to fix the lake itself. But we still have polluted water coming into the lake. You saw that graph of all the water in the, so we got to fix that too. So these are, and you know, right now, the inflows to the lake, we want it to be about 100 tons of phosphorus a year, and it's averaging around 500. And they did some estimates, and it looks like we may have already put enough phosphorus in the watershed to have 500-ton years for the next several decades. Yeah, so we can't just sit here and wait for the watershed to wash out. We're going to have to do projects upstream of the lake, and again, a lot of work is going to need to be done. Yeah, I can't really see, so. Yes, sir.
There's a lot of effluent from sewers and things like that in the early days, you know, but the septic tanks or nothing. But, I mean, until they get a lot of that stuff, I mean, I think that would be a bigger problem, you know, a bigger problem here, and I assume that it can't be put down through the Everglades.
Yeah, so the question is about septic tanks and their nutrient contribution, and it's really big. Another surprising source of nutrients in the Okeechobee watershed is solid waste coming from the cities, and they convert it into biosolids and they take it out and dump it in the watershed. And yeah, well, you got to get rid of it. It's piling up at the plant. And if you dump it too heavily, which they tend to do because it's a big bulky material, you get horrible pollution problems. And the weird thing about it is the agricultural people that let them dump it on their property, they get blamed for it, but really it's nutrients coming from the cities. And this is one of those things that, again, it's not them, it's us, and we've got to find ways to make energy out of that or quit dumping it in the watershed, because not only it has nutrients, but it's got the PFAS chemicals and all kinds of stuff in it that we really shouldn't be spreading in our watersheds. So, yes, sir? Yeah, the question is it a problem for the water from Okeechobee to go through the sugarcane? No, there's enough capacity to move water to the stormwater treatment areas and keep the Everglades wet. They don't have to have a whole lot of water flow at any one time, but it's one of those things we're going to have to learn how to manage. They're enlarging some of those canals just to give them conveyance capacity to serve the farms that are around there and serve lake water when we need to do that. So that's a concern, but they're working on it. So, yeah.
How's the funding? Do you have sufficient funding to support it?
Yeah, so the question is, how's the funding? For a long time, it was not very good. Actually, Governor DeSantis, for whatever his ledger is, he's been superb at funding Everglades projects. We're getting record amounts of money. The Corps of Engineers also is getting record amounts of money from Congress. And so a lot of these projects that we've been thinking about for 25 years are now being built. And this is, right now, we are in a period of intense construction, lots and lots of progress, and we're really happy. You know, we're finally got all the ducks in a row and the money's flowing, and the agencies are hard at it. They're really doing a great job.
Paul, we're getting a lot of questions on Zoom, so I'm going to tuck a few of these in as we go. How do Lake Okeechobee discharges impact red tide on the West Coast?
Okay, so red tides, just like cyanobacteria, is naturally occurring. It's been here forever. And the analogy the best analogy I've heard is nutrients from the lake and the inland don't cause red tide, but it's kind of like a stray animal. If you feed it, it sticks around. And so the blooms have been longer, they've been more intense, they've been more frequent because, you know, that's what the red tide eats. And if they don't have enough of that, they can't persist, and we've been making the blooms worse with these nutrients. So there's a question down here in the corner. Oh,
Dr. Gregg,
hey, Doug.
what do you see in the last 20 years, say, for instance, this is finally in Central Florida, the flows coming out of their system into the lake. Is it you finding more encouragement that they're taking more controls? You showed an example how the city, what way they're building. Have you seen over the years better control on the north end so it doesn't come into the lake?
Yeah, so the question is, are we getting better control from the watershed? Are they doing better stuff? Unfortunately, I don't think the answer is yes yet. We've done some things that are better, but really we have to kind of replumb the whole watershed before we're going to see a significant change. And there's a lot of projects going on up there, and we're planning more. So I'm hoping that we'll get to a point where we'll start seeing changes in the lake. But so far, you know, the Water Management District has a storage goal north of the lake of 1 million acre feet, which is like 2 feet of lake level. And right now they only have about 80,000 built. They have one big reservoir that would be 200 more thousand. And then they have several projects that they're planning, but they're still only halfway to that goal. So we've got a ways to go. Again, you know, these are huge watersheds. And if you've been to the C44 and stood on the top of it, you can barely see the other side. I mean, these are just enormously big projects. So, you know, it takes 10 years and $1 billion to really make a change because this is such big volumes of water. So, all right. Yes, ma'am?
Would you explain the claws on that bird?
That's a good question. Okay, so this is a snail kite. And snail kites only eat apple snails, which are these big round snails. And the native apple snail is about the size of a golf ball. The exotic is the size of a tennis ball. And so notice how long those toes are and how long those talons are. Snail kites have to have these really long toes and talons to get around this round snail and carry it. And they're so long that if you hold them on your arm, they don't pierce your skin because they don't have any strength. And if you look at the beak, see how curved it is? The snails have a little foot that they can close, and they have a little operculum that closes behind it. It's made out of shell material, and the kite can snip that bill between the operculum and the shell and get in there and cut the columnar muscle and pop the snail out. So yeah, this is all this bird eats is snails. And so if you lose your snails, they really can't eat anything else. They'll try to eat a crawdad or a turtle, but they're no good at it. But they're really good with their long toes and all that. And so, yeah. And they also, you know, like things like rat snakes get in their nests and eat their babies. And I was thinking about that. You know, if a rat snake tried to get in a caracara nest, it would be dinner. But these guys are just so dainty that they can't defend their nest very well. And for a raptor, they have really low nest success.
It sounds like we might have to have Dr. Gray back in the future for a snail kite presentation.
Yeah.
What do you think?
I got a snail kite and grasshopper sparrow presentation. Oh. We're not done yet. Did you have a question?
Yes. How did the people who died in the hurricane help to make the Glades how it is today?
Oh, the question is, how do the people who died in the hurricane help make the Glades how it is today? I think what happened is they realized the challenges we were facing with water and trying to live next to the lake. And one solution is you could move away, but we decided we wanted to stay there because it was good farmland, so we built the Hoover Dike. And now that we have hurricanes, nobody drowned in these recent hurricanes. Even though we still had the big storm surge on the lake, we built stuff to protect people from these problems. So it was unfortunately a bad example of what was wrong, but it helped us understand things we need to do.
Paul, let's take another question from a Zoom attendee. Can you talk about how the Army Corps of Engineers is building new reservoirs and filtration areas, but it seems like none of the water in these areas is meeting water quality levels to be able to continue to drain south? Has there been an update on this project or these projects, or a solution to the water not being clean enough to send south to the Everglades?
Yeah, so the question is, are we getting the water clean enough? And the answer is almost. The 10 parts per billion is a really hard standard to meet. If you drink a cup of milk, it's a million parts per billion. And 10 parts is just really low. But that's what the Everglades is. That's what that periphyte lives off of. And so they've been experimenting with them. And the STA 3.4, it's been getting about to 13 or 12, which is really close, but they have a deadline coming up. And part of it is the higher the nutrient concentration going in, the higher it is coming out. And so we got to not only let these filter marshes do as good as they can, but we've got to keep working with the farmers to reduce their nutrient movement. And so it's an ongoing process. They have a deadline coming up, I think, in 2026 we're going to start measuring and saying you're meeting it or you're not. But they're getting close. And every time we have a hurricane, these filter marshes, they have plants in them. And the plants are taking up the nutrients. But the hurricane comes, kills all your plants, and then suddenly they're not functioning to take up nutrients. So things like that are really a hard challenge. And that's not the fault of the agencies not working hard enough. It's just we got to learn how to manage these systems in Florida. Yeah. Yes?
Has there ever been any discussion about, say, taking 20 feet from the pasture, the farmer, and putting in vegetation that as the water is running off the crop or the pasture, that just say 20 feet of foliage would help keep some of the harmful nutrients from getting into the mainstream of the lake?
Yes, that's a great idea. And what the question is what if we leave buffers between the farm operation and the water, where when the water goes across it gets filtered partly? And so in the agricultural best management practices, you've got to keep at least 25 feet from the water for virtually all agriculture. And some sorts of agriculture, it's 50 or 100 feet. And around springs, we don't have springs here, but up in the springs region, it's got to be 100 feet. So they do have buffer strips. That's part of just best management practices. And enforcing that is up to the Department of Agriculture, but everybody's pretty aware of that. They try that. And again, that helps a lot. And we can do that in urban neighborhoods. We can have grassy swales, and they help reduce runoff. It's surprising how much they can help. So,
Paul, here's another question from a Zoom attendee. Do the sugar farms fill the STAs with their nutrient-laden water, preventing us from cleaning water from Lake Okeechobee?
Yeah, so there's a whole bunch of filter marshes around the rim of the Everglades agricultural area, and they were designed mostly to treat the nutrients from the Everglades agricultural area. There was a lawsuit that went on for years and years. The federal judge said you got to build these STAs and clean this water. Unfortunately, the one that was designed for Lake Okeechobee to treat it in SERP, they thought we only needed about 270,000 acre feet of water, and now we think it's 1 million, which is a problem. They thought they only had to treat it down to 50, and now the number's 10, which is a problem. And they thought the lake water would be about 70 or 80 parts per billion. It's twice that now. So it's not big enough. And so the talk now is, what else do we need to build to get enough capacity to handle Okeechobee water? Because right now, most of the SDAs are taken up by the Everglades agricultural area, but we got to get all this Okeechobee water south too. So it's a work in progress. Yes?
So, I have a pretty complex question.
Good.
So, are we on the point of return, or do we still have a chance
Are we on beyond the point of return? I'm still here. We can, Okeechobee, the SAV, we've lost it. We can grow it back. We've done it several times, and we just got to wait for the water to get right. You guys have lost your seagrasses. You were starting to grow them back, but now I don't know what their status is with the lake releases. Ecosystems are very resilient if we give them a chance. So once we build all this stuff, things are going to be a lot better. The agencies are going to have more options when it rains. I mean, you could put me in charge of the Okeechobee estuary system, and I couldn't keep us out of trouble because we don't have the right infrastructure. The colonel gets blamed for everything, but the colonel has, you don't want to be the colonel. you're going to hurt somebody, and sometimes you'll hurt both of them. And but anyway, as we build this stuff, things are going to get better, but we're going to still have to, they talk about, how there's always road work going on? It never stops. Well, it's infrastructure, and so we're talking about water here, and that's infrastructure. And so we're never going to have to stop improving our water management system. And so SERP is a great big project to try to give us a jump start on getting it right. But we're going to have to keep working on this forevermore because it's our water infrastructure. And we want to keep it, we want to have flood protection, we want to have water supply for people, and we want to have our natural areas and places to recreate. So we have to do this. There's really no choice. So yeah, I have hope, but it's frustrating a lot of days.
Paul, your answer to that question ties into one of our Zoom questions. Why does it seem like the Army Corps of Engineers has a competing agenda versus most scientists?
The Corps has a what?
Why does it have a competing agenda compared to most scientists, or a competing agenda with most scientists?
Yeah, so why does the Corps have a competing agenda? Because they're ordered to by Congress. They have to give flood control. They have to give water supply. Think about Lake Okeechobee. If you want to have maximum flood control capability, you want the lake as low as possible so that when a storm comes, you can put the water in it. But if you want to have water supply, you want the lake as high as possible so you have a buffer. And so we have one body of water that we want to keep it low and we want to keep it high at the same time. Yeah, how's that work? Well, we all know. And then they also have an environmental mission, they have a navigation mission, and so they are ordered by Congress to take care of all these different things. And they just have to do that. And so, for a person who has a certain interest, if you're in ag, you just care about you. And if you're in recreation, you just care about you. But the Corps is required to take care of all of us. And, again, it's hard. And something about the Corps, they're trying this recession this year. We'll see how it goes. They can stop it if it looks like it's not going to work. 20 years ago when I went to them and said, the lake's a mess. And they're like, sorry, that's what we do. Yeah, and 20 years ago when you guys are going to them and saying, you can't release water this week, we have oyster spawn going on, and they're like, that's what we do. And now they actually have calls and they get input and they try to the extent they can, they try to help with these things in real time. And so there's been a sea change in the way they act. They still got this 1940s jalopy to drive around in, but we're trying to update it, and that'll give us a better future. Yes?
With the plans and project, with the constructions that you have, how far can you look ahead to address the future growth of Florida with the existing plans that you have now? Are they in sync with the growth? Because if you're planning now, it may not be sufficient for the future growth of Florida.
Yeah, so the question is, how do you plan for growth? I mean, if we build it to fix what we have now, then it's not going to be sufficient for the future. The agencies actually have, like for water supply, they have 20-year plans, and they look for population projections and water use projections, and they start trying to build that stuff now. But yeah, that's a really challenging thing, and it's the same with our roadways. You get on the road and you can't get anywhere. If you go to Kissimmee, you're stuck in traffic jams all the time because they didn't plan ahead well enough. So that's an ongoing challenge, and again, we're going to build this. It's going to make things better, but we're still going to have other needs, and we're just going to have to keep working on it. So how do you plan for growth? You scream.
Let's grab another Zoom question. Compared to historical rates of flow, how long does it take for water to flow from the Kissimmee Basin to Florida Bay through the engineered system of canals, reservoirs, and STAs that we've built?
I don't know. Yeah, so historically it would take like 6 or 8 months to empty out the Okeechobee watershed. it would get into the lake, and the lake has a residence time of a couple years. And then the water in the Everglades would take probably several months also. So it's hard to tell, but it used to be very slow, but with the canal, canal's like the freeway. If you drive through your neighborhood and hit a stop sign, that's like the pristine Florida. But you build a freeway and that water really goes. And so that's what we're trying to take the freeways and damp them down and keep the water in our neighborhoods.
I don't see any hands at the Blake, so we'll take another Zoom question. You mentioned a minute ago that the Army Corps' view on the lake and lake management has changed over the last 20 years. So this person's wondering what changed to get the government more invested in the future of Lake Okeechobee.
I think what changed is they got so many angry people at them. And, and we all call of our senators and representatives and say, hey, this isn't good. So, they've had to respond to public opinion and public needs. And, we also have evolving societal goals. It used to be we'd just dump our sewage into, the city of Kissimmee used to dump their raw sewage into Lake Toho, their own lake, and it made it a mess. And then everybody's like, yuck. And so they decided to clean it up. And so that's kind of what, you run into these problems. And so the Corps responded in kind. The Water Management District has too. You work with those people. They can't always do it, but they will at least listen to you and say, well, maybe we could try that. So it's good if people will at least listen to you.
And I think that's a good question to wrap up with. It's a reminder that your voices and your knowledge matter, and we're seeing real change in the way that the environment's managed in Florida because of concerned citizens like you. So let's give Paul a big thanks for helping us become more aware of this issue. What an incredible lecture. And I do want to quickly mention that we had just under 200 people here tonight at the Blake Library. We had just over 200 people watching on Zoom. So our audience is over 400 people tonight. If every one of you went and told 2 or 3 people something you learned tonight, that would create a groundswell of impact, and that's how we're going to move forward with fixing these problems.
Because
folks,
they knew it was a swamp creek.
the Swamp King is here. Folks, thank you for hanging out to the very end. Remember, 1 week from tonight, we're going to have a really fun presentation with Dr. Ellen Prager and Dave Jones. Show up early if you'd like to participate in the book signing. We'll see you in a week. Thanks, everyone.
Thanks,